So we've got this number 3.375, and we want to have that in a fixed point binary number. And we're going to say that our format for our binary is, we'll do this, we'll say whole dot fractional. So we got a byte, 4 bits for our whole number and 4 bits for our fractional number. So we're going to say that we've got that as a constraint. So what we're going to do is we'll first convert this guy, right? And hopefully we're to the point where we might be able to do stuff like this in our head, where this is 0, 0, 1, 1. All right. And now that leaves us just the fractional component, right? So we're going to bring this down, and all we do is we just keep multiplying by 2 until our fractional part is 0. So, and there's a couple nuances in here. So let's start with 0.375, and we're going to multiply that by 2. And so this turns out to be 0.75. Now we're going to take this fractional part, just a fractional part, which doesn't really matter because this is 0. We've got 0.75. And we're going to multiply that by 2. And what's that leave us with? 1.5. Now we're going to take 1.5. Or sorry, we're not going to take 1.5. We're just going to take the fractional component here. So we're going to leave this 1 behind, and we're going to take just the 0.50. And we're going to multiply that by 2. And what are we left with here? Well, we're left with 1.00. And this 0 means stop. So the way this works is these whole number parts represent our bits from our conversion, and namely this one here specifically is our most significant bit. So we've got 0, 1, 1. But wait, we've got 4 bits available here. What is this final bit? Well, it's going to be 0. If we wanted to, we could take this one more step here, and we could say 0.00 times 2 equals 0.00, right? And we'd still have 0, 1, 1, 0. So what that really means is we end up with 0, 0, 1, 1. 0.0110. So that's a number that we can represent. Obviously, we can't represent every fractional number with this. Let's look at a case where we wanted to represent the number 0.2. So if we want to represent 0.2, let's do another color here. Let's just do this. 0.2 multiplied by 2 equals 0.4. And now we're going to take 0.4, multiply that by 2, and we get 0.8. And then 0.8 times 2 is 1.6. And then we're going to take 0.6, multiply that by 2, and what do we get? Well, we get 1.2. Now, something that we should notice here is, first, we can't fit this whole number in 4 bits, right? We can't fit this whole fractional number in 4 bits. It just won't work. And as it's going to turn out, we can't fit it in any number of bits. We can approximate it, but we can't actually get it exactly. Because watch what happens. The next step here is going to be 0.2 times 2, right? and so that's going to be 0.4. And what we've got here is a repeating sequence, right? Because now we've got 0.8, and then 0.8 times 2 is 1.6, and then 0.6 times 2 equals 1.2. It's just going to repeat, so that means that 0.2 in binary is 0.0001100110011 all the way forever. So that is part of the difficulty with dealing with fractional numbers in binary, but just something to be aware of.